Hey, how are you this morning? We'll give folks a couple of minutes to see if they're up and around yet before we get started. Alrighty, so we're going to go ahead and get started with today's live session, and as folks come in, if you have questions, as always, you can type them in, or you can speak up. It's all up to you. If you're not asking a question, though, it's helpful to keep your mic muted. So, for the last couple weeks of class, we're going to be focusing on probably the two primary tests that actually let us answer research questions and test hypotheses in quantitative research methods. That's ANOVA and regression. This week we're focusing on ANOVA, which looks at the categorical independent variables. Categorical variables, and this is something that's in your textbook, they're very simply variables that it's like gender, so male, female, other, where you need to know a category for someone. It might be where they're living, it might be their gender. You can even break age down into generations. So if I were interested in the difference between, say, baby boomer attitudes versus Gen X versus Gen Z, I could name those as categories. The thing is that we can assign numbers for the purpose of doing data analysis, but the numbers really are meaningless. It's not like if I say, on a scale of 1 to 7, tell me how much you like or dislike something. In that case, the number has meaning. It's a scale or a continuous variable. So that's one of the important things to differentiate between the types of tests. If you're looking at categories, oftentimes you'll want to do an independent variable, especially if you have multiple levels. What I mean by a level is, let's say you have geographic location like we do in our study. You might have the Let me get tests sorted out with the call link. Skype be helpful here. So you might have like region we were looking at. So if you're trying to figure out if there is an impact for region on people's attitudes, for example, is there a difference between how folks in London think about grocery shopping from people in Wales compared to people in the Northeast, Northwest? We have all these different regions. You want to make sure that you can test for differences between them. That's a categorical variable that typically is going to be one you're going to want to use an ANOVA for. We'll get into that in just a minute. But so we're focusing on ANOVAs because we're looking at categories to begin with. So in your Blackboard site, this is the basic information for the week. So our objective is very straightforward. We want to learn how to run and interpret one-way ANOVAs with some post-hoc comparisons. We'll talk about all that in a minute. And then second, we want to be able to apply those to evaluate specific hypotheses or particular predictions. So if you haven't already, please take a chance or take the time and look at the ANOVA and ANCOVA introduction separate from the example data session that we have. And you can download the notes for the ANOVA from the notes page, of course. Once our session's done, I'll be posting the link to it so you can rewatch it or watch it if you weren't able to join us. And then, of course, is the exercise. So we'll go through the step-by-step instructions as soon as we talk about the ANOVAs in general. But before we begin talking about ANOVA, I wanted to go over our first couple of exams and our first couple of, well, they're not really exams, but homework exercises that you have that you're doing online. So the first one on the factor analysis that we did, the average mark was really good. A 62% is particularly good, but there are a couple of questions that seem to pose a particular challenge for folks. The first one of these was this question: based on the results of the factor and reliability analysis for component 1, what is the most reasonable conclusion? Now, one of the things that you want to make sure is how, when you're interpreting factor analysis, how conservative you are and what the purpose of the factor analysis is. So remember, we're not assessing people's attitudes towards values in this case. What we're assessing is how consistently they answered the questions. So that's why the answer was a variable including broadly liberal values can be created with a high degree of reliability. That's the purpose of the factor analysis. So the second answer, participants strongly identify with liberal values, we simply don't know. That's not the purpose of the factor analysis. So that's not a conclusion you can draw from it. And then the other two questions weren't particularly relevant for most folks. But this is the big differentiator. Remember, running the factor analysis is about identifying how the questions group together, not the results. So you run the factor analysis in order to go from many questions down to the core factors. And if you need a bit more of the discussion, go back to our conversation about it from that week. But it's important to know the difference, that you're not actually testing how much people do or don't value liberal values in this case, that it's only about whether the questions work together or not. The second question that posed a bit of a challenge was which of the questions should be grouped together. And this was just based on the reliability analysis. These are the options that worked. The beliefs and values environmentally friendly. I avoid buying food with too much packaging. I prefer to buy food that's been locally produced. And I prefer to buy paper products such as toilet paper or tissues or recycled ones. All of those had the 0.6 or higher level of the factor analysis for component 3. You know, conceptually, these work together. It's being environmentally friendly. But all of these could have been environmentally friendly. They just didn't work together. So the ones that aren't checked didn't have the reliability of the 0.6 or above. So make sure that that's the cutoff line when you're looking at those columns in the factor analysis. It's important that you're looking for 0.6 and above in each of the columns in order to make a judgment as to whether or not they go together. The homework 3 on the t-tests was more challenging. The average mark at 58 is still pretty good, but there were kind of more varied problems or challenges that folks had across. So I thought I'd go over the questions that were the most challenging or problematic across the group. So the first of these is this one. Which of the following statements is or are accurate summaries of the finding for the paired samples t-test when you're comparing Little, Morrison's, and ASDA? So you could choose any of the above. So all three of those bottom ones that are checked made sense based on the question. The top one did not, and let's take a look at why. So on the paired samples t-test, remember, we're looking to start in order to find out whether something's significant, we're looking over here on the right side at what's circled the significance for the two-tailed. In order to be significant, it has to be 0.05 or less. So all of these numbers, even the pair 1, the comparison between Little and Morrison's, is 0.05 or less. So that's why the first one isn't possible as an answer. It's an incorrect answer, was because there are significant differences on the monthly spend report between Little and Morrison's. So that's the critical one that it seemed like threw most folks off. The next question, and this one was, I think, challenging because you had to find the report and make the judgment based on this. So comparing the proportion of respondents in this questionnaire to the actual population of Scotland, is it fair to say that Scotland was represented overall in this study? So in the study, there was about 8.5% of folks from Scotland that were included in the study. Now, this was the link that I had given you guys told you to look up on there. If you take a look, and it's under item 7, you have to scroll a good few pages down, you get the UK share of the population. So Scotland has 8.2% of the population of the UK and was about 8.5% in our study. So it's actually a pretty fair statement to say that when you compare the proportion of the respondents to the population of Scotland, they are well represented, accurately, fairly represented in the study. So this question is more about being able to make a good conclusion based on the data, based on something external that we know to be true. A lot of times when we're doing research, we need to make sure about how we can generalize to a population. And so one of the questions is it representative? That's the type of reasoning that a lot of times using the descriptive data that we need to make. Another question that gave a number of folks a challenge, and this is basically in how we interpret and look at the tests, is that which of the following numbers should be reported as the primary test statistic? That's the T. So if you take a look at the monthly spending between Little and ASDA, the test statistic for the t-test is the T. That's going to be different for different tests. But so then you look down the column, and what's the closest one? A negative 5.29. And if you see what's circled, the negative 5.285 is rounded up to 5.29. That's what we always do, is we round to 2 decimal places. So that's the answer that should be there. Now this one, again and again, I think what happens a lot of times to folks when they're looking at the crazy printouts from SPSS is sometimes it's really easy to get lost in all the numbers that are presented. So it's asking you, what's important is that you start kind of just breaking it down piecemeal. So you're trying to match up the findings in terms of either the frequency or the percent of folks that were asked that were from the different regions. So London, in this case, when you're looking at 123, you have option of either the London or the Midlands, but the Midlands wasn't on our list. So you had the choice in looking at 123 or looking for 15.5. Well, 15.5 isn't on the list, but the 123 is. So that's circled in the purple. Wales is circled in the red. So you're looking at either the percent, the 4.8%, or the number, frequency, which would have been 38. In this case, the 4.8 is the one that was on the possible answers list. Scotland, we already talked about at 8.5, and then the Northwest at 86. So it's just a matter of making sure that you don't get lost in the data. And this is a really common issue for folks when they're looking at data for the first time. And especially because I know that SPSS tends to give you this laundry list of tables. A chunk of them are useful, others are not so useful. So make sure that when you're running the analyses and then when you're looking at the numbers afterwards, you kind of keep focused in mind which is the table that I should be looking at. And then this question, based on the based on the descriptive statistics for household income, which of the following best represents the mean income for the participants in this questionnaire? This was a tough one because there's kind of two steps that you had to go through. So the correct answer is 30 to 49,000, 30 to 50,000 pounds basically. So what you had to do first was to look at the average, and that's the bottom left. The mean is 4.22. But because this is a categorical variable, 4.22 doesn't necessarily mean anything. So a lot of folks answered there's no way to determine, which is incorrect. All you have to really do is then you go back into the variable view. And so if you look here on the bigger graphic that's in the kind of middle and to the right, this is our variable view. If you're going to try and identify what the values are, when you scroll on this, and we'll look at it in SPSS in a minute, you click, there's three little dots that'll come up here on the right side of each of those cells. When you click on it, the value labels come up. So this week when we're talking about categorical data, that's actually really important to do, is that you have to convert the mean sometimes for categorical variables into what does it represent in terms of the categories listed. So 4.22 means that for the most part the income we would expect to fall between 30 and 50,000. So it can't just be the 30 to 39.99, because then it would just be 4. It has to be slightly above that. So the best range for the mean based on the data that's available is somewhere between 30 and roughly 50,000 pounds. So sometimes you have to go fishing for your answer, but there's always a way, based on the data that you're given, to answer those types of questions. And then the last one is this question. Based on these results, it's fair to say that people like Morrison's more than they like Little. True or false? A number of folks said false, and this also is about how do you accurately interpret your data. Now, there is a rationale you could say for saying false, if you look at and under here, the top of the ones that are circled, the paired sample statistics with the mean, yes, it is fair to say that people spend more money every month at Morrison's than they do Lidl. So the £27 on average versus £21.78p, of course that's more. Does it mean though that they like it? That's not actually measured in this particular response. So the reason that it's false is that we're only looking at how much do they spend. Alternatively, if you can offer an alternative explanation, why might people spend more at Morrison's? Well, they might spend more because it's more expensive, or because it's closer to them. There's a whole host of reasons why people might spend more at a particular grocery store that haven't got anything to do with liking the grocery store. So if you interpreted this based on the significant difference, that there is a significant difference between the two, then you're almost there. It's just, do you have enough data in this case to draw this particular conclusion? No, what you can say is that there is a significant difference in the amount of money that people spend at Morrison's than they spend at Lidl. But you can't necessarily make a particular conjecture as to why they spend more money, just that it is significant and they are spending it at Lidl. So this, for the most part, what I can see in people's responses and in their tests is that you guys are doing a good job of running the tests correctly. It's just sometimes that the harder bit is interpreting, or even in the sea of printouts, seeing what you need to see in order to get the answers. That's okay. Oh, Harriet, thank you for saying that. You should be, but I don't think that I have. Let me make sure that I've shared it. Let's get in the. Come here. Where are you? Share screen. There we go. This will be on. Good question. This will be on the YouTube bit later on. So if you haven't seen the screen and haven't seen the YouTube live, take a look at that if you have any questions. Sorry about that. Apparently 2 weeks have decayed my brain. So when we come back to those are all the big questions as far as ones that created a more consistent problem for folks in the last couple of weeks. So it's really good. It's, like I said, it's clear to me that you guys are running the tests correctly, and that you are able to kind of get through things. It's just sometimes, what do you make of the information that you've seen? And that's something that I would expect at this point is more likely to be the challenge for folks. So when we come to the ANOVA, the analysis of variance, again, what we're going to be looking at is it's asking a very simple question very broadly. Is when we have a category, say gender, is there a significant difference between the way men and women in this instance judge something? So in the context of grocery shopping, is there a difference in the way that men and women go value shopping? That's the kind of question that an analysis of variance would test. So what we're trying to do when we run an ANOVA is explain what we can see and then reduce the possible error that there could be. So we're always trying in statistics, inferential statistics, we're always trying to reduce the possible alternative explanations that there could be. So when we say something is statistically significant, that has a bit of weight because it says to basically 99.5 degree of certainty, we can say that our conclusion is true. Now, with the t-test, we were looking at the t. ANOVA uses the f-test. So in our printouts and everything, what we're going to see this week is we're going to be looking for a capital F instead of a little t. Don't worry about the reasons, it's just important to know that that's what you're looking for. And we're always looking for the probability that the observed differs from chance. So we make 150 jillion observations and judgments a day. Slight exaggeration. But do we make those observations and do we draw those conclusions based on the best available data? One of the interesting conversations that's coming out this week with regard to COVID is about the use of face masks in public. Now, when we're talking about face masks, we're not even talking about necessarily the quality of that it needs to be a surgical grade mask. What there is research that bizarrely the Public Health England folks are not liking to pay attention to is that a multi-nation study has found significant differences, so no chance involved, that countries where there are face masks being used have reduced rates of transmission. Why? It's not that if we put on like a bandana so that we look like a proper Old West, bandit or something, that we reduce our chance of getting it, but what we reduce is our chance of giving it to people. So this is one of the reasons why in the countries that are coming out of lockdowns right now, that like Spain, Germany, Italy, in Europe, and then Asia has a much bigger history of wearing the face masks, that they're wearing the face masks, it's not to keep from getting stuff so much as it is to keep from giving it to others. But what's interesting about this, and there's a clip of a scientist being interviewed on Peston from late last week that said, well, how do you know this? And the guy said, because we've looked at the data from 16 different countries, and we have been able to scientifically conclude there is a meaningful difference between countries that are using them and countries that don't. So when we're talking about this probability, when you hear scientists in particular talking about this kind of a finding, this is what they mean, is that they are able to look at what we can explain and what we can't explain and mathematically account for it. So when we're talking about understanding statistics and the impact that this kind of research, any kind of statistical research, can have in terms of public decision making, and even when the government is saying, we need to look at the science of it, this is actually what we're talking about. We're talking about ANOVAs, we're talking about regressions, we're talking about t-tests, and this notion of that our observations can be taken from what we do in our daily lives and say, well, this seems to work or this doesn't seem to work, and we're putting a mathematical test on that to see if it really is more than just chance. So at the heart of it, that's what ANOVA is trying to do based on the groups. So the independent variables for this are always nominal or categorical. You'll hear the two words are synonymous. So you can either hear nominal variables, which just means names for variables or categories. So like male, female, like regions of the UK, anything that is sort of education level. So what we'll be looking at in this week's demonstration is level of education for your homeworks, and then for the demonstration itself, we'll look at employment status. So those are both categorical or nominal variables because they come with a description. So we'll take a look at all of those when we get into the demonstration itself. However, our dependent variables are always going to be interval, ratio, or scale. And again, all three of those, there's slight differences in the meanings for us most of the time. It just means that they're a continuous variable. That if someone puts a 1 for an answer, that is different than if they put a 7 for an answer. Most likely to strongly disagree, strongly agree, like versus dislike. So they're anchored for most of us in this statistical research at one end or the other, but that the numbers themselves carry with them a degree of meaning. All that we are going to focus on, and ANOVA can get really, really complex, but we're only going to focus on one-way ANOVAs. So if we use our microbrew example from the week, our last time when we were talking about the t-test, an example of a one-way ANOVA research question would be, are there differences in the intent to purchase microbrews between types of sports fans? So in a U.S. context, hockey, soccer, or baseball. So if that's the question that we were looking at, that's really a question for the ANOVA. So our independent variable would be type of sports fan. We're asking, and then our dependent variable would be purchase intention. So let's say we asked a bunch of questions that basically boiled down to, are you planning on buying our microbrew, or a microbrew, or this type of a microbrew? Those types of questions. We had our factor analysis, and we said there's an intent to purchase microbrews. That's our dependent variable. So every person who responded would have been somewhere on that 1 to 7 scale, or 1 to 5 scale, whatever our scale was. So that's a scale, it's a continuous variable. But we want to break it down to see if we should be marketing, particularly to say hockey, soccer, or baseball fans. So those are categories of fans. And say that those are fairly different populations in the U.S. actually. So we want to see if there's any statistical significant difference. You can also pose these as hypotheses. Let's say that we knew that soccer fans, for example, football fans, properly like microbrews, and they seem to buy them in larger amounts than other kinds of sports fans. So you could then, if that was where your previous literature, where previous research had found, you could make that a hypothesis by saying, football fans are much more likely to purchase microbrews than other types of sports fans. And that would be one way that you would shift between a research question and a hypothesis, is just based on what do we know from previous research. So, but the difference between them in terms of running the test, that doesn't matter. So whether you see something posed as a research question or a hypothesis is only based on the literature review, not necessarily the study design. But let's say that these are our results. And this is how you will see results written up in academic studies. What the heck does this mean? Well, let's go through each of these numbers. So first, the F, anytime you see a capital F and it's italicized when you're seeing statistics, it tells you that it's an ANOVA. The 2 and 199 represent your degrees of freedom. What this is telling you are the total number of levels of your independent variable, or compared to how many people were in this study. So there are a total of 201 people who were in this study. How do I know this? I add 2 to 199. So the 2 always represents the number of variables that are included. And then from there you subtract that from the total number of people in the study. Don't worry, you don't even have to do that mathematics, because that's already done on the tests themselves. The third number is the value of the F-test. Again, that's calculated for you. And then finally is the probability that your findings are due, the p-value. So the p is always the same. We always look for the p or the significance. That's always going to be the same, and it's always, we're looking for numbers less than 0.05. So if these were our results, and if we were answering the question, how much does the type of sports fan influence people's intent to purchase microbrew, what would this tell us? Well, it tells us that there is a significant difference in terms of the type of sports fan and their intent to purchase. That is the basic conclusion without post hoc tests that we can come to, is that amongst our independent variable types of sports fan, there is a significant difference. And that is as much as we can interpret from this finding alone. Now, if this were a 2-level variable, so we only had, let's say, gender, male and female, and then we had discounted anyone who answered other, recognizing that there will be folks that answer other. If we were only looking at male versus female, or we were only looking at hockey versus baseball fans, we can then go to our means, the averages, scores for this, and interpret them, because when there's a significant difference and you only have 2 levels, the higher is different than the lower one. With 3 or more, it becomes a little bit more complex, and there's an extra step that we have to take. We'll cover that in the demonstration. So if the F statistic is significant, it helps us to interpret the effects. And so once we know that we have a significant result, then we look at the means. What are the higher means? What are the lower means? And that's also why we consider the follow-up test, the post hoc contrast. There is no point, though, in looking at the post hoc test, and post hoc just means it's the test run after the main. You do it all at once in SPSS, but it's done as secondary. So if you don't have a significant result, then guess what? You don't look at the mean, and you don't look at the post hoc. You only say this result was not significant. So as a general introduction to ANOVA, that's where we're going to start. And so let's have a quick peek at your homework, and then we'll do the demonstration. So close that. So the step-by-step instructions for your homework. And let's make this bigger so we can see it. So it is due this Friday by 11:59, but you have up to 2 weeks afterwards to get it in. So just like the other ones, if you want to go back to it, or if you can't finish it up for this week for any reason, you have a couple of weeks to get it in just in case. So the first step is that you're going to be evaluating 2 hypotheses related to the amount of education and the influence of that on people's values and the type of cost-reduced shopping profile that they report using. So what you're ultimately wanting to do with the data analysis that you're doing is be able to come to a judgment as to whether or not the hypothesis, each one of them, would be fully supported, mostly supported, partly supported, or fully rejected. But to do this, you're going to have to run several one-way ANOVAs and then be able to evaluate the conclusions, evaluate the results, and come to a conclusion. You'll also need potentially to run some post hoc tests, and we'll show you how to do that in the demonstration. So step 2 is running the test, and again we'll go over this, but you can see that the screenshot is available. Step 3 is how to do the post hoc test, and then step 4, once you've done that and taken a look at the results, then you can pop into the exercise and complete it. As always, you can work with other folks. I encourage you to do that because a lot of times it's easier to work through everything. So let's take a look at the data. If you haven't downloaded it already, I would encourage you to go back real quick into our session and download the data file there. But when you come into it, now I wanted to show you again on the identifying the category. So on the values, when you can see none, 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 that's basically telling you that they're the scale or there are continuous variables. However, where you see the variables themselves, if you click here, that's where you get what each of the levels say. So a lot of times, if you're looking at means, you'll only see the mean listed, and a lot of times that doesn't tell you a ton when it comes to ANOVA, but that's how you figure out what each of the levels are. Now, most of the tests will have these, they will use these labels instead of just the numbers to make it a little bit easier, and you'll see what I mean when we run through it. So you all, for your test, for doing the tests on your own, you're going to be looking at education. For our demonstration, we're going to be looking at employment and taking a look at the impact of employment status on different beliefs and values. Oh, I hate it when it does that. I'm trying to open it up so you can see it. Well, on different beliefs and values and types of food shoppers. So to do that, you go to Analyze, then you drop down to Compare Means, and you come over to the one-way ANOVA. So the first thing that we do is we want to put in our independent variable. That, what they mean by factor, is our independent variable. So we highlight employment and we put it over here. The nice thing about running the one-way ANOVAs is we don't have to run our test 9 different times, because we have 9 different variables that we want to consider. So we highlight all of our variables that we want to consider for the dependent variables, and we put them in this big list. So when we go into the options, we go into the post hoc, select Chiffre. There's a whole lot of tests and people have different preferences. The Chiffre is a relatively conservative test that really looks for the fine differences between different levels of your independent variable. It's commonly used, and so it's one that I would recommend. There will be folks who use Tukey and LSD, and not in a good way. But the Chiffre is the one that I tend to use. There's good support for it. On the options, you may want to choose your descriptives so that you can look at the different means, and then click Continue. And that's all that you want to check. So once you have added in your post hoc and looking at the means, then you can run your one-way ANOVA. Now, for now, this is your descriptives. You can zoom past that and go just to the ANOVA test. So if we're in the ANOVA test, let's see, can I make that bigger? No, I cannot. So if we're in our ANOVA test, again, we start with our significance column. So for any of these values that is higher than 0.05, we know that there is no difference that our level of employment makes in terms of the beliefs and the values. So in this case, if you look down at this significance column, what you see is that most of them are significant. The only 2 that are not are environmentally friendly shopping behaviors at a 0.14, not significant, and also type of food shopper, people who are trying to minimize food waste. So level of education, or level, of employment, does not influence those 2. However, the rest of them are all below 0.05. Now, if your hypothesis is that you expect to see significant differences between people based on their employment status, this is great news. It means already that your two hypotheses, were mostly supported. So if we go back to, and I'll open that up again, sorry. But imagine that instead of this level of education, respondents' employment and respondents' employment, if these were the two hypotheses that we were considering, already we would be able to draw this conclusion, that they are mostly supported. But we don't want to just leave it there, because that doesn't tell us a lot. At this point, we can't make a reasonable conclusion as to where there are and are differences. But so that's why we go to the post hoc tests, because with level of employment, as we see in our data, we have 5 different ways that people can be employed, 5 different employment statuses: unemployed, retired, student, part-time or people who work multiple jobs, and full-time employment. So we don't want to just leave it at, yeah, there are significant differences. We want to try and dig in deeper. But again, we're always trying to reduce chance. So if we went up here, since we know that social responsibility is different, we can take a look at this second column, the mean column, which is on a scale of 1 to 5, how much did people identify with values of social responsibility? And we can see the difference that students and retired tend to strongly agree with this much more, more so than unemployed, part-time, or full-time workers. But the question is that really meaningful? So even though we can say that there are significant differences, where do we draw those lines? So when we go from the significance, we know that it's true. We look at our means to see where some of the differences might be. Then we come down to the post hoc analysis. Now, this is under the multiple comparisons. When you're looking at this is the comparison between the groups for the different levels of employment and the beliefs and values of social responsibility. The way that you look at this is much like how you look at the t-test, and functionally that is what it's doing. So the first group, the unemployed, that, notice up here that's the I. The I doesn't mean anything, it's just an abbreviation. It's the first one that it's comparing. And then under the J, employment is just the second one that it's comparing. So in our t-tests, we had to run each test individually to see if there were differences. That is functionally what this post hoc is doing. So our first line, when comparing unemployed to retired, there's a difference, the mean difference, the next column, of a negative 0.15. This means that unemployed people had a lower rating because it's a negative number. Their mean was lower than retired. So if we go back up to this, we can see that that's true. So retired people have the mean of the 4.05, unemployed 3.90. So that's how those number, the I minus the J, is derived, is subtracting unemployed from retired. We get that. Don't worry about the standard error, but then again, look at this, we have our significance column. And as always, we're looking for 0.05 or less. Take a look at this column. You don't see any numbers that are less than 0.05. What this means is that even though overall in the ANOVA test there were differences between the groups, no single one of them on its own was significant. So even though you can statistically say that employment influences how much people identify with social responsibility, and you can rank order them, so that when you're looking at this, you can say that students generally identify most with social responsibility values, and who is our lowest? Full-time workers generally identify least with social responsibility values. That's as much as you can say about that. You can't draw any conclusions about how that those are significant differences because the post hoc has no significant values. So you would do, but at the same time, if you look at the significance test for the ANOVA at a 0.04, that isn't unexpected because you're bordering on that 0.05 cutoff. So while it's significant, it is not a huge result. So let's take a look at our highest one. We look at our F test, and let's look at the highest number. So the biggest difference there were, based on employment status, was this very bottom one. The type of food shopper impulse sale. How do I know that? Well, I look at the F value. 8.21 is a bigger value than any of these others in the list. So let's see if we can make any comparisons based on employment status for people who impulse a food sale. So basically what this was asking them, when you go into a store, if you happen to see something on sale, do you buy it just because it's on sale? A lot of us shop this way, by the way. But apparently it significantly varies depending on your employment status. So let's take a peek at the descriptive statistics, which are right here. So what can we see? We see that folks who are retired are the lowest on this, 2.86, and people who are employed students actually, take that back, are the most likely to be impulse sale shoppers, at least when it comes to food, with a 3.5. Let's see if these see any significant differences on our post hoc. So we scroll all the way to the bottom, and here is our type of food shopper, impulse sale. Hi, Frankie. Frankie is here saying hello, the dog. And so we take a look at numbers that are less than 0.05, and aha, look at this. We have a good few of them. Quit being a pest. So what we can take a look at here is actually, it's our retired shoppers. So we have here, when you look at this, it's the 0.01, 0.01, 0.00. So the student, part-time folks, or multiple jobs, and people who are employed full-time. And when you look down at the rest of the list, at any number that is less than 0.01, it's in the comparison with the retired. So we can just look at this section of, nope, that won't let me do it. Can't just highlight that. Sorry about that. We can just look at the retired section for this. Now, what I also want to highlight is on the means difference. That's the column right beside the names. See the asterisk? It tells you which ones are significant in and of themselves. So you look for the asterisk as one way to see, and then you go over to the significance column and you can see the significant test there. So what we can say is that retired folks are significantly less likely to buy stuff on impulse just because it's on sale compared to students, people with part-time or multiple jobs, or full-time. So if you're trying to get, let's say that you're trying to get more people to shop overall, and think about this as a conclusion, you actually have a pretty fair shot of just putting up random sales in your store to improve sales when you're talking about most people. So students, people who are employed at all, are much more likely to be impulsive sale shoppers than folks who aren't employed, because actually if you take a look at this, the one that isn't statistically significant is the retired to unemployed comparison. So that's actually quite an interesting comparison, that you can suck folks into spending more money in your store by putting a few things on sale on pretty much any reduction. It doesn't even have to be a meaningful reduction, that people who are employed or students will see a sale and are much more likely to pick up that object that's on sale, that product that's on sale. People who are not employed, either retired or just simply by being unemployed, they're much less likely to do that. So then the question would be, how do we explain that? There might be research that talks about things like disposable income, that people who are on very fixed incomes, who aren't students, might be looking to really be careful about what they spend, that they're not, in terms of food spending, they don't want to waste, so they're much more cautious about those kinds of purchases. So this is why we look at the post hocs, is that it gives us a lot more to talk about. So whereas with the social responsibility, we can see that employment status, generally influences it, we can't talk about a lot more than if we take a look at this kind of deep dive into the data, which is what the post hoc analysis lets us do, and it lets us make much more interesting conclusions. So when we come back to, though, our hypotheses, we can say that our hypotheses are mostly supported. But then once we go through the post hocs, we have a lot more to say about that. Now, when it comes to doing research in practice, having a lot more to say about that is actually where the value comes in for employers, for organizations. That's where they can start to make strategic decisions. So if they know that the majority of their customers are going to be are much more likely to be employed, guess what? Put stuff on sale. Even if it's just a small reduction, as long as you're still making a profit on it, you're probably going to make more money than you would do otherwise if these kinds of things weren't on sale. So when you go from the statistical test through the practical application of it, that's where it starts to become interesting, and that's when you start to have better decision making for organizations. Reasoned, fact-based decision making can come in based on the types of data that you run. So that's what ANOVA can give you, is it gives you, are there differences in critical groups? So for us in public relations, for people in marketing, the group identification when we're talking about target audience is critical. So you'll see a lot of ANOVAs run in market-based research, trying to identify what types of people, what types of consumers like or dislike the organization more or less, or different aspects, what kinds of ideas and innovations might the organization want to try out. That's why this kind of research is really useful in making decisions and reasoning based on this kind of decision, because we have a better idea as to what types of promotion strategies, engagement strategies, what have you, might be more successful for organizations. Are there any questions based on that? So what we'll do is I will end the stream, and then I will stay on as I have done on the call itself, and then we can, if you have additional questions or you need some extra help, I'll be on until noon, and you can ask whatever questions that you might want. Let me get